AI has taken over the world, which means that AIs are more data hungry than ever before. But how do you source all of that data as a developer? Well, one of many ways that have been relied on since practically the start of the internet is something called web scraping. What's web scraping? First, let's define a few things. Querying is the process of asking for data from a server, which in our case is us querying for the website's HTML as if we were users. HTTP is the protocol used to exchange these web pages, and HTML is the actual code that makes up the meat of the web page. Now, back onto the question itself. Web scraping is the process of loading websites as if you were a user, but instead taking the raw code of the website and extracting data from it. This is useful for when websites don't have easy to use APIs, or they're too expensive, for instance, looking at you, Reddit, and for generally getting data from multiple websites with more general scrapers that can scrape more data. Now, here's the actual code. Remove white space is used so that we can decrease the amount of work that has to be done in certain cases by making it so that we have less stuff to loop over for if we plan on expanding this in the future. Although, to be honest, a lot of the times it's just used for consistency and more than it needs to be. Safe mkdir is how we safely create the directories containing the data by simply using the OS module to check whether or not the directory exists, and then simply creating it if it does. For the actual web scraping, we first query for the HTML from the website's main web page using requests.get URL, and then .text before we find the navigation bar at the top of the website via .find, which finds the starting portion of the navigation bar's HTML. This will be repeated for finding other parts of the HTML for other data extraction. Then, in order to get each section, we simply split the string based on open bracket, li close bracket, which is what each section starts with, and we remove the unnecessary parts of the navigation bar via sections.pop, which will pop the unnecessary parts in the list before we finally remove the HTML surrounding the URLs containing section URLs via a bit more string manipulation. We repeat about the same thing to extract the number of pages from the counter at the bottom of the category page, loop over those pages, and then extract the skin URLs for each section, and then, again using the same methods, we can extract the skin's name and description from the skin's page. However, extracting the skin itself isn't as easy since it isn't text that can simply be queried in the same way due to it being a binary file, in this case a PNG. For that, we do another request.get query with the download URL, but instead we enable streaming and decode content before we use the shutil library to copy the binary data into a file. We then store the metadata, the name and description, and the skin, and then the name in the URL to store the data in a category slash URL name. And then in that directory, the skin.png and meta.txt format, allowing for easy querying of data. And in case any of you guys are wondering, I also created a script to convert this to an image folder on Hugging Face for easy use with machine learning projects, which I plan on doing in the future, as stated before. Now, here's some things that a lot of scrapers include that weren't included in this more simple scraper, that you might want to know if you plan to make more complex and powerful scrapers. Some scrapers parse HTML into stuff like tokens and syntax trees, among other things, but for this case, the HTML was simple enough for us to not have to worry about that. However, if you do plan on parsing the HTML of more complex websites, using these sorts of tools will greatly increase how easy it is to parse things, compared to pure string manipulation like shown here. For scraping larger websites or maybe simply scraping faster, a lot of scrapers use asynchronous and multi-threaded code. These offer their own distinct advantages compared to the synchronous approach that we took. Asynchronous code is able to send out a bunch of queries at once, and receive a bunch back, instead of sending a query, waiting for it, then sending another, then repeating, which, as you can imagine, is a lot faster considering the fact that sending stuff over the internet takes time. The multi threaded approach is a lot faster due to being able to do everything separately on different threads, which means that instead of doing queries, parsing, and repeating just on one thread, each thread could do that cycle for its own part of the website. This wasn't included due to the fact that it would have increased the complexity of the scraper and have made it much less beginner friendly, as well as being complete overkill for the website that it's meant to scrape. If you want to find out more about how these help to increase the speed of doing things over the internet, I recommend that you check out my recreation of Copenheimer video, in which I make heavy use of asynchronous and multi-threaded code in the bot created in the video, which utilizes the current most dangerous Minecraft exploit to discover completely private Minecraft servers, and where I explained how it functioned. And for those who came here just to complain about developers scraping data off of websites, I'll probably have a video out for you guys about why I believe that this practice, as long as it doesn't harm the websites themselves, is completely moral.